Once again, welcome to my YouTube channel, Matthew Eats with Ease by Mr. Kamotho. And in this video, I want us to look at example 5, 6, and 7 in the same video of number 10, and you're still looking at surds. We're looking at simplification and other operations of surds. And example 5 is telling us to simplify root 18 plus 2 root 2. And if you look at the two parts of the question, we have root 18 and we have 2 root 2 on the other side. And 2 root 2 cannot be simplified further because root 2 will remain root 2. And we can only multiply 1 by 2 to make 2. And none of them has can be simplified further because root 1 is still 1 and it remains the same. But root 18, as we have seen in example 4, we can simplify root 18 into root 9 times root 2. So this one becomes the root of 9 times the square root of 2. Of course, now this one plus 2 root 2. The square root of 9 is 3. 3 times root 2 is 3 square root of 2 plus 2 square root of 2. And at this particular point, we have 3 root 2 plus 2 root 2, which is 3 plus 2, which is 5 root 2. And that is the answer to that question. Number 6, example 6 rather, we are being told to express 5 root 6 as the square root of a single number. And I want us to be careful and keen here. 5 root 6 as the square root of a single number. And I just want to use example 5 above, the one we have solved. 5 root 6 is exact in the same form as 3 root 2. There is a rational number outside and there is irrational number under the root, or rather the surd is irrational number. But how did this 3 find itself here? Of course, before 3 came here, it was the root of 9 after simplifying 18 into root 9 times root 2. So 9 has a perfect square root, which is 3. So 3 taking up this position means there was a number which was under the root, and that square root gave us 3. So that number must have been 9, and therefore root 9. Now that 5 is a rational number, there must have been a number which was under the root, and that square root gave us 5. So which number whose square root is 5? Of course, it is 25. So 5 is the same as saying the square root 25 times the square root of 6. That is how the whole of this expression can be written. And because the question is express 5 root 6 as the square root of a single number, so we just have, just like we talked about, 9 times 2 to make 18, and the whole thing under the root. So we are going to just have 25 times 6. We're just going to have 25 times 6, which is 150, and that 150 will itself be under the root. So 150, and that is the answer to that question. Example 7, simplify root 81 over 49. And you can see the whole root is extended, or it is extending to the denominator. We can as well put a bracket there at least to have more clearer meaning to the question. And I want us to, first of all, understand one small thing here. For example, if we happen to have the square root of, let's say, numbers which are easy, and we know 9 over 16, this is the same as saying 3 over 4. And before we can do that, how is 9 realized? Of course, 9 is 3 squared all over 4 squared. The whole of this now is under the square root. This is the same as saying the square root of the numerator separately and the square root of the denominator separately. We can easily say the root of 3 squared, which is 9, over the root of 4 squared, which is 16. Well, we know very well the square root of 9 is 3, and the square root of 16 is 4. And that is how it goes. In other words, we are simply saying the square root of A over B is the square root of A over the square root of B. It's like having the roots of numerator and denominator being found separately. And this is the same as saying, now our question, the square root of 81 over 49 is the square root of 81 over the square root of 49. The square root of 81 is 9, and the square root of 49 is 7. And that is the final submission to that example. That is how best we can explain that example. Thank you so much. Please follow, share, and of course subscribe, and let us meet in the next video.